All right, so let's get started by looking at an example of a quadratic equation that would be familiar to us based on what we did in lesson one. And then after that, I'm going to add a little bit of variation to what we're calling quadratic equations. So take a look at this example. We have 10 equals 4 times the quantity x minus 2 squared plus 5. So this isn't exactly the same example of what we had in the last section, but very similar. And remember that what we are trying to do, just like we always want to do whenever we're solving an equation, is that we're trying to get x by itself. So our key was we needed to isolate the variable. Specifically I'll just say isolating x. We also needed to know that the square root will undo a square in the same way that division and multiplication undo each other and addition and subtraction undo each other. And then we also said that whenever we take the square root in an equation, we need to get a plus and minus answer. And that's how we get our two solutions, x equals whatever and x equals something else. And that's what we learned in that first section. So all of that remains true, but I want to show you an example of an equation that is a quadratic, but we would find it difficult to solve using the process that we've discussed so far. So here's an example. Let's say we have 0 equals, actually I'm not going to write it that way. I'm going to say 0 equals x squared plus 6x plus 9. So the first question we have to ask ourselves is this a quadratic? And I can say, yes, it is a quadratic because it has an x squared term as the highest power. So it's not like there's an x cubed term or x to the 10th or x to the 100th. The highest variable power that we have here is x squared, and that happens right here. Now I could say, let's solve this by trying to isolate the variable. But check this out and see if you can find the problem. After you think about it for a moment, I'm going to show you that we have x squared plus 6x plus 9. How many variables do we have here? We have x squared and we have 6x, then a number here. Can I combine x squared and 6x? Are they like terms? Well, the answer is no. We can't combine an x squared and a regular x term. Can I then isolate one of the variables? Well, we could try, let's try to get x squared by itself. Well, that would mean we'd need to move the other pieces to the left, which would give me negative 6x equals x squared. Have we isolated the variable? No, we have a variable on the left and a variable on the right now. So what on earth are we supposed to do? That is the big question. Quadratics don't always have only one variable. And when we try to combine like terms to get them together, sometimes we just can't do it. It was easy to try to isolate the variable in this first example because it was the only variable. We could move all the rest, they were all numbers. So now we're faced with a bit of a conundrum. What do we do, with examples that have two variables within them? And I'm going to stop this video here and show you how we're going to attack that in the next video.